Hi Goggle, you look busy. What are you working on, buddy?
Hi Toggle, I'm calculating the total price of groceries for Mom for this week.
That's a long list, Goggle.
Yes, but this calculator is helping me a lot. There, that's done. I will write this figure now and give the sheet back to Mom later.
Good work, Goggle.
I couldn't have done it so fast without the calculator. Toggle, it is so useful in doing all these calculations.
That's correct, Goggle.
Imagine, Toggle, people must have spent hours simply adding before calculators were invented.
Well, Goggle, that is not entirely true. Even before the invention of the calculator, there were various simple devices which helped people calculate faster.
Is that true, Toggle? What devices could those be? Can I see any of those devices?
You surely can. In the City Museum.
Can we go there today?
Why not, Goggle?
Okay, come on then. Let's go now. Toggle, look at that. Why is this toy in the museum?
Well, Goggle, the abacus is not simply a toy. It is actually a calculating device.
Wow, somehow I always thought it was just a toy.
The abacus was probably the first calculating device invented thousands of years ago. You can see that it has a wooden frame with beads sliding on wires. In early times, it was used to perform simple calculations like addition, subtraction, multiplication and division.
That's great, but tell me, Toggle, where was the abacus used first?
Well, Goggle, some of the most popular and useful abacuses were developed in China, Japan and Russia.
Do people still use it, Toggle?
Oh yes, the abacus is still in use today in many countries of Asia and Africa.
Toggle, look at that strange thing on that table. What is that?
That is Napier's bones.
Napier's bones? What were they used for?
Napier's bones was used for addition, subtraction, multiplication and division, and to even find the square roots of numbers.
I see. But then why is it called Napier's bones?
Well, Goggle, this calculating device is called Napier's bones because it was first created by Sir John Napier in the year 1616.
That's all right, but why bones?
That's because the original device had numbers carved on rods made of bone. Later on, metal or wooden rods were used.
Wonderful device, I must say, this Napier's bones. Look at this instrument, Toggle. Doesn't look like a calculating device to me.
Goggle, that device is a pascaline. It was the first mechanical calculator.
Wow, the first calculator. Why is it called a pascaline?
It is called pascaline as it is named after its inventor Blaise Pascal.
Look at the pascaline, Toggle. The rectangular box has tiny wheels on it. I wonder how it was used.
These wheels were actually dials with the numbers 0 to 9 around each of them. When you want to enter a number, you take a thin metal rod, place it between the spokes of the wheel at the position of the number and turn the wheel. The number will appear in the window at the top above each wheel at the end of the turn. The pascaline could be used for adding, subtracting, multiplying and dividing numbers up to the hundreds and thousands.
That's neat. Toggle, tell me one thing. Could any of these machines carry out big and complicated mathematical calculations?
Well, no. The devices like the abacus, Napier's bones, and the pascaline were suitable for carrying out relatively simple calculations only.
So, when was the first device for carrying out complex calculations invented?
Yes, look at this picture on the wall. It is the image of the difference engine.
Difference engine? What was that?
Well, Goggle, you can say that the difference engine was the first computer. It was made by Charles Babbage.
Charles Babbage! Yes, I remember. Our teacher told us that Charles Babbage was a great scientist. He is known as the father of modern computers.
You are right, Goggle. Charles Babbage made the difference engine to prepare mathematical tables. And you know, Goggle, Charles Babbage made the analytical engine too.
The analytical engine?
The analytical engine was the first general-purpose computer. It had some basic elements of the modern computer like input, output, and memory devices.
What a wonderful device the analytical engine must have been.
Imagine, Goggle, from the abacus to the analytical engine. Such wonderful progress.
Thank you, Toggle, for this visit to the museum. Now I know so much about the early calculating devices and their inventors.
I enjoyed this as well. Time for lunch. Let's go home now.
This is how we do 23. 23. Always start counting from left to right. You think 2 tens and 3 ones. Plus 37. 3 tens. I exchange to 150. And then I put in 7. Exchange 5 ones to 1 5. And 2 5s is exchanged to 1 10. And the result is 60.
Digit. So if you had 26 times 47, you have got a 2-digit multiplied by another 2-digit, so you need to draw a 2 by 2 grid. So we're going to write 26, 47, and you could have these two numbers the other way around, it doesn't matter. We're going to now put the diagonals into our grid, and we extend these diagonals outside of the grid. Each box in the grid, you've got to think of that as the tens part of the box and the units part of the box. Okay, so we're going to look at 2 times 4, which gives us no tens and 8 units. 6 multiplied by 4 gives us 24, which is 2 tens and 4 units. 2 multiplied by 7 will go into this part of the grid, and I get 1 10, 4 units, which is 14. And 6 multiplied by 7 gives me 42. That's 4 tens and 2 units. Okay, you've got to remember now that we have finished using these numbers, so it's always a good idea to cross those out. We now have 4 diagonals in our grid, and we're going to add up the numbers in each of those diagonals starting on the right. So 2 is not added to anything else, so it's just 2. 4 add 4 add 4 gives me 12. So we have the 2 here. We have to remember to carry the 1. 2 add 8 add 1 gives us a 12 again. Put the 2 there, we carry the 1. 0 add 1 gives me 1. We now have the answer just on the outside of the grid there. So 26 multiplied by 47 is this number here, 1222.
For example, if we want to add 38 plus 42, the first thing to do is entering the numbers 3 and 8 in the rightmost dials respectively, like this. Basically, This is the row of ones and this is the row of tens. I entered 3 in the tens place by putting the stylus in the appropriate place and rotating it clockwise until the fixed stop is reached. That will show the value 3 in the output window in the tens place. Same procedure is to be followed to enter 8 in the ones place. Put the stylus in the correct place and rotate the spokes until it shows 8 in the output window on ones place. To add 42 with 38, you have to dial 42 with 38 using the same procedure. In the tens place, we have 3. We need to add 4 to that. Move the spoke near 4 clockwise till it reaches the fixed stop. That makes the value in the tens place 7. Now we need to add 2 in the ones place. For that, rotate the spoke near 2 till it reaches the fixed stop. That will make the value in the ones place 0 and it automatically adds 1 to the 7 in the tens place, making the value in tens place as 8. That happens because the value of 8 plus 2 is 10. The digit 0 stays in the ones place and carries the 1 to the tens place, making the value in the tens place as 8, which is 7 plus 1. Same like normal addition. So we got the value 80 in the pascaline and that is the right answer.
And what Hollerith comes up with is this, the data punch card.
Each of these holes represents one piece of data. So a hole here tells you it's male, a hole here that he's 40 years old, and this hole means he's married. But Hollerith's real breakthrough wasn't the punch card itself. It was the realization that these cards could be processed by a machine.
You take a stack of punch cards, you feed them into the tray here, and then press the button.
These machines use small pins to read the data on the cards and then sort and count them. Some machines could sort over 2,000 cards a minute. By the early 20th century, these systems had become an essential tool for businesses and governments. And it all started with the machine Hollerith created to help the census takers, his tabulator.
What this technology does is gives people the ability to process large amounts of data by machine.